Retrieval-Augmented Generation, or RAG, has become the industry default for feeding custom data to AI models. But if you have built a RAG pipeline, you know it is hitting a performance wall. Traditional RAG operates on a transient loop. Every time a user asks a question, the system runs a vector search across chunks of raw, unstructured documents, blindly stuffs those raw snippets into the LLM context window, and asks the model to figure it out. The result is prompt bloat, high latencies, and lost-in-the-middle context degradation. Once the LLM generates a transient answer, it immediately forgets everything it read. Andrej Karpathy calls this the transient RAG trap, where valuable compute is repeatedly wasted to rediscover the same underlying facts. To solve this prompt bloat, Karpathy proposed a shift toward compilation. In software development, we do not compile source code on every CPU cycle. We compile it once at build time. Karpathy suggests we treat LLM agents as wiki compilers. Instead of running vector queries at runtime, a compiler agent works background shifts. It reads raw PDF manuals, chat transcripts, and databases offline, resolves contradictions, deduplicates facts, and compiles the information into a permanent, interlinked wiki graph using tools like Obsidian. At query time, the system bypasses vector databases entirely. Instead of guessing based on cosine similarity, the downstream agent loads the exact compiled concept page it needs, guaranteeing highly accurate, zero-noise results. Google Cloud's newly launched Open Knowledge Format, or OKF, is the industry's first vendor-neutral standard for this compilation paradigm. OKF is designed to bridge the gap between Karpathy's idea and production-grade engineering. Rather than storing documentation in proprietary databases or closed formats, OKF packages knowledge as simple directories of Markdown files. By combining standard files with a lightweight YAML front matter header, it establishes a unified structure that is version-controlled in Git, easy for humans to edit in standard text editors, and simple for AI agents to crawl and index without complex parsing libraries. Inside an OKF catalog, each file represents a single, distinct concept, like a specific metric, API, or runbook. The YAML header at the top of the file contains a mandatory type field which acts as a polymorphic dispatcher for AI agents. Underneath the header, the body of the file is written in standard Markdown, but the magic lies in its relative links. By using standard Markdown link syntax, nodes reference each other bidirectionally. This creates a portable, traversable knowledge graph. Because these links use relative file system paths, the entire directory can be zipped, cloned, or shared without breaking references, making it completely independent of proprietary hosting platforms. At query time, when a downstream agent needs to answer a technical question, it does not search across millions of disconnected text chunks. Instead, it utilizes deterministic graph traversal. The agent loads the target concept page and automatically pulls its one-hop or two-hop dependencies. This gathers the complete, contextual neighborhood of information and packs it cleanly into the prompt. Because the compiler agent already resolved contradictions and removed noise at write time, the downstream agent receives a perfect, structured context window, eliminating prompt bloat and preventing hallucinations. By standardizing our context boundaries, we free organizational knowledge from silos and build structured, portable APIs for the future agentic era. Compiling your documentation into standard OKF directories today prepares your codebase for the next wave of autonomous agents. Subscribe to Use AI with TechDad for more technical deep dives, and check the description below for links to the official OKF specification.